Next speaker is hailing from Germany. How are you, Florian?
I'm great, thanks.
All right, we have Florian here from Samtap. Oh, I'm going to mess up that name. I got it so perfect when we did the stream before. So Samatop. I didn't get that right, did I?
No, but it's fine. I will repeat it.
I'll repeat it again. I totally had it right the first time. Now I just 3 hours of hosting and 3 hours of streaming earlier today. My brain's gone dead. How do we say it?
Smapyot.
Smapyot. I knew I had. There was something in there about smap and snap and it and ought not it, but Smapyot. There we go, everyone. We have Florian from Smapyot, who is bringing in the party life. So Florian's going to be talking to us about micro front ends or front ends with Blazor. So I will leave the party to you. I'll share your screen as well, and it definitely looks like we've got a party. I see Lego. I'm excited already. I'm going to hand this wonderful audience over to you, Florian.
Thanks for the kind words. Yeah, we only have half an hour, and I want to make it count. So let's get right into the topic. The Lego there is, yeah, these are all our different front ends that should come together. And we want to mix in Blazor. And I want to answer in this talk also what are micro front ends and how we can use them with Blazor. First, a little bit about myself. My name is Florian Rappl. I'm a solution architect at Smapyot. Yeah, Smapyot, kind of an artificial name. That's Smart APIs for IoT. So what we are doing is IoT embedded computing, but also a lot of digital transformation these days, and specifically in distributed web applications. I'm also working a lot in open source. So I'm a Microsoft MVP for development tools. I do a lot of contributions to projects in .NET space. I can now say .NET since it's all unified again. Don't need to distinguish here. And also the JavaScript ecosystem, of course, almost exclusively using TypeScript. I write a lot of various articles for blogs and magazines, and currently also I'm writing a book about microfrontends, where I spent the last couple of years doing architectures and deriving solutions in that space. So I now want to motivate what brought us to microfrontends. If we think rather quickly and very simplistically, of course, about, well, let's say state-of-the-art system architectures, what comes to our mind in the backend? Well, microservice, right? So what we have is we have a lot of different services. Best case, of course, each service has its own, let's say, single responsibility. And then we build kind of a mesh of these services. So the interactions between these services, they can get rather complicated, but nevertheless, we do that still because it gives us, of course, some gains. If we think about it, why do we want to have microservices? They are, of course, not the ultimate solution, but a nice way to go forward because they are already scoped around business capabilities. So really, we can make one business capability, one service. We can then let these microservices be developed by autonomous teams, which is always an advantage, right? Each team just has their own maintenance, has their own life cycle. They can choose, are we having 2 or 3 week sprint? Are we going agile or maybe in some other fashion? What are we doing? That being said, they're still kind of loosely coupled ideally, and that means we could turn off a service, maybe it goes out of the service discovery, and maybe that whole system still works. Of course, if certain flows still work, that's then up to what our business logic should do. And best case, of course, they are technology independent. Well, that of course has also flip side. We don't want to have, let's say, 50 services written in 45 different languages and frameworks. But nevertheless, we can choose the best tool for the job, which is awesome. Now, if we think about the front end, that is usually still a monolith, right? I mean, we have just this one solution there. It's maybe one team that does it. If there are multiple teams, they always step on each other's toes. We have therefore larger deployment cycles, and that is not really ideal. We can now ask the question, of course, how are these massive web applications, these tools created? Let's think of, yeah, I know, older screenshot, but still, of course, somehow applicable today. The Azure portal, web app that we know very well. we see that there are a lot of different functionalities in there, and it's nearly impossible for one team to do that. I mean, it could be a giant team, of course, but still it would be a massive need for alignment, and that cannot be the thing. Also, of course, if you know a little bit about the internals of the Azure portal, there are some cool possibilities here. So you can have certain feature flags enabled, disabled for you, and then suddenly you have new functionality or not. Which is quite nice, and it gives you always the possibility of, let's say, trying out things. Of course, you can now argue, well, the Azure portal, that's coming from Microsoft, and Microsoft has a lot of development resources, so creating such an application on your own is pretty much impossible, right? But I don't think so. One counterexample is, let's say, a project we did with a famous German customer here, which created kind of a customer portal. I wouldn't say similar to the Azure portal, but of course also tool-like and with similar customer benefits, where you can bring in all kinds of different features that are then rolled out, specifically targeted towards the end user. Now, the specific targeting, that's not, let's say, the only major achievement here. All these different features are also developed completely independently, deployed completely independently, updated completely independently. And so we can have all these different teams, some may be internal, some may be external, to come together and create this very consistent, very cohesive experience that for the end user just feels like one thing and always brings new features, has a very high velocity and very, very good customer adoption. So what you could do is you could say, oh, we have now this particular part of our application, let's say this picker here, and for this we want to use a certain technology, maybe because we already have this in some other technology, for instance, written in Windows Forms, and we say, oh, okay, porting that over with the business logic is maybe not feasible to whatever we want to do, let's say JavaScript. But if we could remain in Blazor and then render these things differently using some HTML snippets, of course, we could win. So what could be done in such a solution is that you go in here and you say, oh, part of that whole web app that we have is consisting of different components coming from different teams, and they may be written in different technologies. One of these technologies may be Blazor. Right. And that brings us now to Microfrontends, because as you already thought of the title, this whole architecture style that I just described with the different components being, let's say, completely independently developed, that's called a Microfrontend architecture. And the name, of course, is no coincidence. It should resemble that it is quite similar to the microservice approach. So what can we now do in a Microfrontend architecture? Let's first look at, let's say, some idealistic picture, what we could do. Our backend is now a little bit flattened, but it's still the same microservice backend. Let's say we have services A to D. And what we place on top is just different, let's say, web servers, frontend A to frontend D. And now we have this. We are done, right? So instead of, let's say, service A just serving now some JSON, it now serves HTML, and the same for B, C, and D. Now, that doesn't need to be a one-to-one correspondence. And of course, one of the tricky parts is also missing here. How do you now join these different microfrontends that you have, right? Because maybe service A gives you a list of users. Service B has now a list of roles for these users, but how do you now display the users with the roles, right? Well, do you just display a link in frontend A, and then you just jump over, you have a completely new page? I mean, you could implement it like that. And that's actually one of the viable ways of doing microfrontends. But it's actually, well, not maybe what you want to have in a front end. Additionally, of course, how do you bring a common layout to that? You could now argue, well, I have these different pages and they just need to agree on a layout, and each page just implements the layout. It's a viable way too. Again, this is a very idealistic picture. So usually what you want to bring in is some kind of a layouting engine that sits on top of these. And if you go then forward, it must, let's say, join these different snippets coming from the different front ends, etc., etc. And so you can, if you now stack that up, starting with that picture, reach a solution where you say, this is now my Microfrontend solution, and it just works. Each team just is responsible of one slice here, and it's done. Now, what we want now to do with Blazor is we want to use Blazor WebAssembly, so dominantly client-side rendered, and want to join these microfrontends in the browser, in the user's client, right? And for this, what we propose is an architecture that doesn't use a dedicated web server for each microfrontend, but just packages each of these microfrontends in kind of a module. So we now have these packages, module A to module D in this case, and we wrap them in a let's say, common architecture that we call an application shell, or in short, app shell, that also comes with some other things. For instance, some shared libraries, core and common capabilities. There may be even a pattern library in there. A pattern library could be as simple as Bootstrap or Material UI. Could also be a custom thing. And if we combine that, we have a modular distributed web application. Now, as a whole, that reminds us a lot on a plugin mechanism. But that is at the end what we want to do, because what we want to have is actually a pipeline where we can encourage to have different separated teams that can deploy independently, develop independently, debug independently, and of course have their own lifecycle. And if they just publish to the core application, there is no rebuild or anything needed for this. It just happens at runtime. And the best thing about this architecture style, of course, is that now for different users, it's very easy to just say, oh, module D, well, this requires administrator privileges on the service, so let's don't ship it. It wouldn't be functional anyway. And so you can really decide what you want to bring to the front end. Plus, of course, you can lazy load all of that. You can say, oh, module C, well, it's available for the user, but the page that is delivered by module C is currently not shown, so you don't deliver it. So you can get a single page application experience that can just grow indefinitely, is still very performing, and leverages to have separated teams, maybe even full stack teams. Now, that's something you can decide on. Let's check our two options that we have in Blazor. The first is, let's just use NuGet Packages, right? So our app shell is now a Blazor WebAssembly app. We just have some used libs and our design lib, and we can bring different packages from NuGet, right? Just assemblies, it's all good. This kind of creating, let's say, distributed web apps, well, is not new with Blazor. This is how we did it since a long time. I can still remember a project that was very heavy involved in, where we did that, I think, for an ASP.NET MVC3 application. We brought in the area feature at this time, and then each area was delivered by a different assembly, which were at the start of the server retrieved via reflection. It was a quite cool mechanism, because this application was then, of course, distributed to clients for an on-premise installation. And depending on the plan, the clients had different libraries have been activated and on their server. So quite a cool thing. And again, we can do the same, but keep in mind there are some disadvantages. So if we say, what are the advantages? We say, okay, it stays complete in the flow. We are 100% using, for instance, Visual Studio. It's all Blazor code, all C#, is great. It's all the mechanisms we know. However, it would require recompilation, or of course this dynamic reflection, which, well, is not so easy to achieve with our code now sitting on the client. So recompilation would be required. Cross-framework support, we've seen that is something microservice had. That's not in there. So how can we use React and all that? We would stay in Blazor here, of course. And it needs a full evaluation before starting. So also the lazy loading aspect may not be fully given, right? Because we need to inspect all the different assemblies coming in to know what's in there. That may be quite heavy and not really achievable. Of course, one can go for an approach to split one assembly into multiple and have a carrier assembly and lazy loading then fragments from the others. That is possible, but out of the box, not really in there. So therefore, let's see how that would look like if we would, let's say, implement that. I've created a very simple code. If you follow me on Twitter, I'll share the link to all these samples afterwards. They're all very simple and to the point, I'd say. So what we are doing here is we are just adding a library specified now via a component sitting in that library. And if we watch that video of me navigating around, you'll see, okay, the crucial part here is the add library. That function is actually just an extension method. If we go in there, we see we just add now the assembly, and we maybe add some specific items like the nav items here. We add them to the menu items. So going forward, the assemblies are used for the routing because, the Blazor router will then know all the pages. And then in our layout, we have a nav menu. We can join anything in the nav menu, but importantly, we are just dynamically rendering now the items from these collector menu items. And that's it. If we do that, we are done. We can extend this solution, of course, in other areas as well. Similar principle, if we want to have some dynamic components used somewhere, just do something like this. And it just works. Our main application only at one point needs to know what we want to bring in, only in our configuration, which is quite great. And potentially, you could even optimize that. So the second approach I want to highlight here, and then I want to go into the challenges of this approach, is we can combine it with JavaScript. So what if we start with JavaScript and then say, Blazor is just another technology in there? What does that give us? It leaves us with the advantage that we can recombine now freely. We can combine React with Blazor, with Angular, with Vue, whatever. Additionally, lazy loading of Blazor is suddenly possible. We can use just a simple JavaScript or even maybe a JSON metadata file to transport where our Blazor components sit, where they should be registered. We don't need now to have any Blazor assembly loaded already in the client to say, there's this page from Blazor that we want to use. Of course, there are disadvantages too. It's much more complicated to do that, to publish this kind of solution correctly. And worst thing is we need to mix JavaScript and C#. But if you know Blazor well, then you know there are certain things you can only achieve with JavaScript because, Blazor is running in the WebAssembly virtual machine, and it anyway needs to communicate. So if, there is something from the document object model, something specific that you want to do, you need to have this interoperability abused and, have just a jump in the communication path to JavaScript. And so it's similar with this approach. All right, there are then some challenges. Challenge one, routing. What do I mean here? Let's say we have an application and there are two things in there. One is our entry point for a React app. The other is our Blazor. So React comes from the simple React.js and our Blazor comes just from our Blazor WebAssembly part, right? Now, our React fragment here is just using a browser router. It has two routes, foo and bar, standard components. And now the thing is, if we have a layout view in there, then we will never see this. It will always be just hidden. If we remove this, then if we go to a not found view, it will be empty and actually Blazor will say, okay, I have nothing to show here. So we would need to get rid of the not found component or let's say view definition. But there are other consequences. The Blazor internal routing, when we go to the /foo route, will say, I have no route registered for that. So it might be a top-level navigation. So it will reload the full application. That is not a very nice experience. So even though we come close with just removing here the layout view, lines 6 to 8, we are not there yet. And it's kind of a struggle. We are using the navigation engine from Blazor, but that one was never meant to be used, let's say, generalized. That's a problem, but it can be overcome. Challenge 2, DOM projection. Now, let's say we want to have a Blazor application. It offers multiple components, and one of these components should be shown now in a menu of our full application. Of course, it's simple when it's all Blazor, because then we just say, yeah, in the menu, let's just place it there. But what if it's not all Blazor? What if this menu is actually rendered from React or just in vanilla.js? How can we bring in this one snippet from our Blazor rendering tree to this menu? And the solution is a projection that we do. To show you the idea, I prepared the following sample. So this is not code you should use at home, but it gives you the idea in what direction that goes. And actually, it's also possible in a robust way, of course, requiring a little bit more code. So what we have is we have a div in our top-level navigation, in the top-level app called projection target. And what we have is a function that I just called project that takes a projection source and places it in this projection target. So all it does is it gets out the DOM node and gets it into the other node. Now, Blazor will not know that it was moved because, yeah, it just takes the references. So if we have this projection source here, which displays the current count, then we can just do that. Let's go to the counter. Let's click it, and we see it works. But let's now project it, still all functional, and see, it's now there, it's removed from the main layout, and it's still functional. Blazor can still update it. The reference is still intact. Now, of course, you wouldn't need to clean it up. It just stays there. If we go back, well, Blazor thought it cleaned it up by cleaning up the parent node. That was not the case. And so here we can have a little fun and abusing this simple example. But you get the idea. In the end, it's all about getting one DOM node out, making sure it was not the top level node, because then Blazor gets into trouble. So it must be somewhere down there in the tree, and then project it somewhere else, and it will just work fine. Cool. Challenge 3, dynamic registration. The idea here is, what if we want to dynamically bring in more components? Now, this example is a little bit, let's say, more artificial than the others because it has some logic, but I want to have this logic to show just how dynamic that is. So we inject a special service, component activation service, and then we have a placeholder component. That will actually show the dynamic registrations, so all the components that we registered. Now, clicking the button in that view will just, well, have some logic to register one or unregister. Actually, by activation, we can just bring in instances of these components. So first click, register them, and then if we continue clicking, then we will just cycle through, and we will always get the first component instance, a second one, we will remove a second one, and so on. And this is then the code for actually rendering it. We need, of course, to listen to some state changes. But then we just abuse the Blazor render fragment. Again, first click was we registered, and now an instance is shown of the first component, instance of the second. Remove the second component. On the next click, we replace it with the first component instance. And so we get now in more and more instances of the first component. And again, there is no thing here that says, well, this is it. It's actually taking it from this dynamic source, and so we can dynamically register components and extend that. Next challenge, shared components. What do I mean with shared? Components from other frameworks that have been shared. That they can say, oh, yeah, I got now this cool thing. I don't know, a counter written in React. Let's just use it. So here we have a page in Blazor, and we're using this external component from Blazor, and we say, oh, our component name is title, component name is counter. The external component was defined like this. It presents a div that has a special ID, which we then use later to render in, well from the other framework. And the render ID is just built on a GUID. And so when we render an external component, we just invoke this render React function. That's it. We give it the component name we want to render and the container ID. The code is quite simple, right? In here, we just get one of our shared components via the component name, and we render into the element with the ID of the container ID. That's it. And here we see this definition of a simple counter in React. It starts with 0 and it just increments when we click. So very straightforward, and we can see that this works already by the design because I didn't apply any classes. So this is just a standard button, right? And you can see it just mounted, unmounted as you would expect. So very simple. And again, both things here, the counter and the title, these are externals that have been shared, and these are both rendered from React. So you can render actually multiple things. Due to the time, I spare the lazy loading. Also, it's solved anyway in .NET 5 with Blazor 5, so to speak. If you want to know more, there is a great link. It will be a little bit fast, but if you just search on Google for Blazor WebAssembly lazy loading, you will also find that, or in the changelog with the announcements of .NET 5. Finally, a quick glimpse at the reference implementation. I don't want to show the code. Code is actually on GitHub. Check the sources. So what I want to show in this video is there are now fragments in there. This is a full application. I disabled the cache. So you saw the loading spinner. And now you saw that after a brief second or so, the counter was appearing. So that's a fragment now coming. This link comes from Blazor. And now we have loaded this counter also, which is coming from Blazor. So quite nice. If we load that again, look at the network tab, we see that the Blazor lib8 just loaded a little bit later. Again, if we enable the cache, it's a near instant experience as you would expect. The fetch of the Blazor assemblies is now fully cached. And again, so this example here that consists of multiple things. The main application shell here is written in React, and all the different fragments come from different microfrontends, and the counter page, those two are coming from a Blazor assembly. And you could have multiple Blazor microfrontends, of course, coming in here. It's just one in this example. All right, this example was done using a framework for that. It's called Pyral. You can check it out. It's still pre 1.0, but it's already used in production for a lot of users and customers. And it has very nice bindings for Blazor. All right, so to conclude, I started with, let's say, more generalized microfrontend architecture. Then we went forward with the architecture for creating distributed Blazor applications. We've seen that there are some challenges, of course, if we want to bring that to a fully dynamic scope with real independent deployments. And in the end, we ended up with just a glimpse at a full framework. But again, having all the different steps and choosing what makes sense for your application is useful. Microfrontends is a topic that gains more and more traction in the recent year. And even though it's not for everyone, it may solve one or the other issue that especially large-scale applications have. Nevertheless, choose wisely, choose what you need for your project. And happy coding, everyone. Also, of course, again, just a little bit of advertisement, my own personal matters. Again, I'm writing currently a book on that. It's currently in preparation, should be released mid of 2021. If the topic is out of interest, it will be released on Pact. Thanks, everyone, for supporting me, supporting my work, and happy to hear some questions and answer them.
Thank you so much, Florian. That was amazing. It's so good to see all the work that you've done. It's really great to see lots of questions coming in from both the Twitch stream, the YouTube, and also on Twitter. Now, we don't have time to answer them all, so I'm going to bring up a couple really briefly. So there's Lara, who's nearly ready to go, so we're going to be jumping into her next. But I'll ask this one because Andrea is actually in the Twitch chat, so this is great. So with Blazor lazy load, can modules of your schema A, B, or C, etc., use different versions of shared libraries or not?
Yeah, it's a good point. In general, it is possible, but it is not so easy, right? Because of you know already, if you if you have different versions of, let's say, a standard assembly in a .NET project, you need to have your binding redirects really well done, and that is not simpler, of course, when it was transported, especially via the name to your browser in WebAssembly. So far, my experience with that, we only had, let's say, 2 or 3 cases where this appeared. They have been mixed. It was quite difficult to tame. I'm not sure of a good solution here. I'd say it is possible, but for me, it was rather difficult, to say the least. So if anyone has good insights, if that is, let's say, if there is something similar to a binding redirect that works reliably on the front end, then I'm happy to hear. The other thing what we did and there to solve it in one case was to introduce an alias and to have, let's say, the name mangled and solve it via that. But that may not always be a solution, especially if it's in dependencies, so dependencies of dependencies that you don't control. Anyway, long story short, it's difficult. So hopefully this is not a case, it appears.
All good things are difficult anyway. That's all we have time for with the questions. I know there's a bunch of people in the Twitter who have actually tagged you in their questions. So hopefully you'll have a chance to go and check them out. So thank you very much for putting your Twitter handle underneath your name. And for all those other people, we hope that Florian can get to your questions. So I want to thank you again, Florian, for tuning in with us from Germany. Thank you for an amazing presentation, and thanks for being with us for .NET Conf this year.
Awesome. Thanks. Bye.
Thank you.